Ladies and gentlemen, please welcome to the stage a representative from Intrinsic.
All right. Good afternoon, everyone. My name is Torsten Kroeger. I'm from Intrinsic. Intrinsic is a sister company to Google, so we are an alphabet company in the same way that Waymo, Wing, and other companies are sister companies to Google. And before I even start talking about AI and robotics, let me ask you, maybe just by a show of hands, who of you works in robotics right now? That is not a lot. Who of you has a background in robotics? Who of you has a background in AI? Okay. And who would like to learn more about robotics? Okay, fantastic. What Intrinsic is aiming at is, our mission is to democratize access to intelligent robotics. And we are a pure software company, so we're building a software and AI platform to radically improve the flexibility, accessibility, and versatility of robots in manufacturing. So we're starting in manufacturing. So we're looking at semi-structured environments where we believe that AI can add utility value to the industry today. So if you look at some of the core improvements that we have been seeing over the past couple of years is really on the hardware side. There are like things like robot arms, hardware and devices, and sensors. And sensors of various sorts. Think of tactile sensors, think of perception sensors for like visual perception sensors. Traditionally though, manufacturing systems have been fairly hard-coded. And if you want to change something, think of like the automotive industry, general industry, electronics industry. It's very expensive and it's not very flexible. And there's a huge opportunity to modernize the software stack that is being used for manufacturing, and specifically for robotics. So the future that we're seeing here is to get to a lot more flexibility, adaptability, a skill-based and scalable system. And when I say skill, think pretty much of human skills. Like think of giving industrial robots a sense of vision and a sense of touch. And in order to do that, you obviously need software. And what we're aiming at is to come up with a software platform that has a number of components that we believe are important. It starts here on the left side with the developer tooling. We want to make sure that developers can implement solutions for customers, for users, in a very simple way. They do not necessarily need to be AI experts or robotics experts or machine learning experts. Like, we're using AI to make the development process significantly simpler so that more people can develop such solutions. In fact, if you look at the labor market, we all agree that there's going to be a labor shortage. But it's not only the labor shortage that we have in manufacturing, it's also that we do not have enough people who can program these machines. And this is where these developer tools are going to come in. For all AI-based skills, data is going to play a role, and therefore security is something that is tremendously important. But in order then to look at like data collection, organizing, enriching, and securing, this also needs to be integrated into the core of the platform. If you look at embodiments and form factors of robots, you can see robots in all sorts of different form factors, and therefore having a hardware abstraction layer going all the way down to real-time control is important for interoperability, standardization, and then the abstraction happening through software. And that is so important. If you just think of the sense of touch that we humans have, the fastest sensors we have as a human are actually here in our hand. And these operate roughly at a rate of 400 to 450 hertz. So if you look at the dexterous capabilities of human hands, if we want robots to do the same, you need to control a robot at roughly a kilohertz. And that's what also needs to be enabled through software. And then last but not least, connectivity. Right? This cannot all happen on-prem. While the system itself may be able to run on-prem, typically the training, machine learning analytics services remote access happens through the cloud. So we as Intrinsic, like I mentioned at the beginning, we're part of Alphabet, and the way we think of ourselves is we have the opportunity here to collaborate with our research colleagues at Google DeepMind, Google Research, Google Cloud, and take a lot of the basic infrastructure, like for security, privacy, analytics, cloud infrastructure, containerization, and bring that out to the industry to create an ecosystem. And partners that we have here are NVIDIA, Siemens, a company called Trumpf, and a number of others as a starting point. And another piece that Intrinsic is doing is we're working on ROS, Robot Operating System. Can I maybe again see by show of hands, who has heard of ROS, the Robot Operating System? That is fewer than I had thought. So ROS is an open source platform that was originally developed for academia and has now found its way into industrial use cases. And it's the world's largest software ecosystem of robotics with like more than 1 million developers worldwide. And that is another piece that Intrinsic is driving forward. So we're developing in a very open source fashion the core of ROS. Now, as a starting point, in order to enter the market, the first product that Intrinsic has announced and developed is called Flowstate. Flowstate is a web-based developer platform that sits on top of the platform, on top of the actual platform infrastructure. So it's a one-stop shop for developers to implement robotics applications for pretty much any embodiment that you need for manufacturing. And what you can see here is you have behavior trees, you have a digital twin, you have a simulator, you have an asset catalog, and you can, in a plug-and-play manner, put the things together for your very application, for your very use case. So you can look at robots, you can bring in force torque sensors, tactile sensors, cameras, and I'm going to show you now a few examples how AI is actually helping a lot here. And helping a lot in the sense to create business value and commercial value. If you give me an unlimited budget, I can implement any application you can think of. But if you have budget constraints, the cost of programming and the inflexibility of programming today is very often prohibitive in order to get applications onto shop floors. So in order now to deploy AI in the physical world, there are a couple of techniques that we're leveraging through the Intrinsic platform. It starts with basic versions of machine learning, reinforcement learning, excuse me, reinforcement learning, for example, for skill parameter optimization, large language models as coding assistants for process tree generation, like behavior tree generation. You can use large language models for debugging, for data analytics, but then also, crucially, generative AI and specifically foundation models. So I want to talk a little bit more about foundation models on the next couple of slides. And now bringing all of this together for industrial-grade AI solutions. And I want to make one key distinction here. There's an opportunity for AI tools during the development process and for AI during runtime. And during runtime, you really want industrial-grade quality. So you want the system to work 99.999% of the time, which can be a challenge given that you're dealing with probabilistic models. Whereas during development time, it's often okay if your system only works 70% of the time. That's enough to assist developers to make faster progress. So looking at specialized intelligence, artificial specialized intelligence, we use it for perception, for planning, and for control. And I want to give one very concrete example now for a runtime example for perception. When it comes to, let's say, assembly tasks or even smart pick and place tasks, it's a crucial capability for the robot to do pose estimation of objects and object recognition of random objects in the environment of a robot. And the interface we're offering here is that the developer just needs to upload a CAD model and everything else is done automatically by AI. And not only that, it works robustly under all lightning conditions. It works in cluttered environments, so that even for like reflective parts and transparent parts, it just works out of the box without writing a single line of code. And that is a key feature when you think of we want to give industrial robots a sense of vision, like a pair of eyes, so that they can understand, semantically perceive the environment and do sub-millimeter accuracy post-estimation of objects in the environment. Now the next step here is you doing the same with foundation models. Foundation models now have the advantage that they work in a one-shot manner. As a developer, you just need to upload the CAD model, and now the training cost and training time is going to be zero. It just works out of the box, and it works on-prem for the customer. Makes it like super, super easy and simple to give robots a pair of eyes and use it in a very efficient way. Again, no coding required for the end user. So therefore, making these systems significantly more accessible so that you don't need highly paid experts anymore to program such robotic systems. So ease of access is really what this is all about. Like I said, if you give me an unlimited budget, I can automate everything. But if I have a limited budget, these are all key aspects that need to happen in order to empower developers through AI to implement robotics applications in a much faster and a much more seamless way that can actually scale. So if you then look at this from an end-to-end perspective, there's the UI aspect, there's the web-based front-end aspect. It needs to work out of the box. But also when it comes to motion planning, for example, it's not pre-programmed anymore. You just tell the robot, I want one part from a position A that is just perceived to another position B, or I want to insert it into a machine like a CNC machine or a sheet metal bending machine. And you do not explicitly need to program the motion anymore. Also, the motion planning works out of the box. Now, if you then look at the talent and the tools, there's an opportunity here to create a new ecosystem. And I was talking about ROS earlier and the million-plus developments in the ROS community. Through Flowstate, we're providing ROS interfaces, however, in an industrial-grade way, so that the requirements that you have in industrial applications when it comes to robustness, reliability, security, privacy, everything that you need over-the-air updates on a customer shop floor is being provided in a new way, in an end-to-end way, like I mentioned, through graphical user interfaces, programming interfaces, lots of simulation, by the way, during development time as well as during runtime in a digital twin. And the people you now need to develop these applications are very much empowered to implement solutions for customers in a cheaper, faster, and most importantly, in a more flexible way. So if you want to change your application, this becomes much, much easier through these new approaches. And let me close by the quote here on the bottom right. It took me several days to program these movements in a conventional way. So seeing this being planned in seconds is amazing. And this is not only true for motion planning. We're getting the same feedback for perception, same feedback for store control. So if you think of assembly type of applications, that it becomes much, much easier, much more flexible to implement applications for end customers. With that, thank you very much. I think we have about 5-6 minutes for questions, and I would like to invite every one of you to come up, grab a microphone, and come up with questions. Thank you so much. Actually, do we have a microphone? Okay.
Excuse me. So, today, we will call like OpenAI API to get an answer. Like in the future, would we just feed like an API the observations and then get like an up, down, left, right kind of command? Or do you think we would need to see something more like this?
So you're asking about OpenAI APIs and how to integrate those ChatGPT APIs in the software stack? Is that the question? Sorry.
Let's say I have a Raspberry Pi,
Yeah.
and I have a simple like motor that just turn the camera around. I could just send it to an OpenAI API for it to control it.
Oh.
But over here, like let's say I want to go towards something much more advanced, like will we be able to have something like that?
So the question is whether we can run intrinsic flow state on a Raspberry Pi and then use an open API on top of it. So right now, everything we do is containerized in order to maintain security and to be able to update the software over the air. And for that very purpose, Raspberry Pi is not powerful enough to do that. What we do offer is you can have an asset. You've seen the asset catalog in Flowstate here on the screen. So you can have an asset in a sensor, in a controller that contains a Raspberry Pi controller. And then we have standardized interfaces, typically just following industry standards like DS4.1, DS4.2, to then connect with Flowstate. But you would not run Flowstate on the Raspberry Pi itself.
Hi. Can you talk a little bit about what the implications are for workers of this of the new software?
The feedback that I just shown you here, this is actually from real workers, real customers. They are happy to get this empowerment. We are also looking at some use cases for example, in the automotive industry, where workers are actually doing jobs that at least I think no human should be doing. Like they can do these jobs, let's say for a year and a half, and until then, like their health, be it their back or some parts of their body, is just worn out. They're basically selling their health to their employer. And if we can use robots to automate these use cases, we believe that this is a true benefit to labor worldwide, actually. But obviously starting here in the US and in Europe.
Just a quick question about robotics in industrial settings. Do you see a future where you have a mobile platform where you can then interchange, self-motivated by the robotic system itself, that they can change the usage, move from one location to another, and then continue to see just mobile platforms that can be interchanged for use throughout the entire industrial process?
So the answer is clearly yes, but I would not limit it to mobile platforms. Mobile platforms is one example. We have one customer, for example, who's telling us, I want my robot to produce product A in the morning, and then in the afternoon I'm going to be working for another customer of mine, and I want to now produce product B. And today with like conventional technologies, the changeover from product A to product B can be hours or sometimes days. And now with a software-defined approach, you can do that in a matter of minutes or in a matter of very few hours. So this is where the flexibility comes from. But I would not limit it to mobile platforms. It's true for mobile platforms as well, for sure. But it is true for robotic systems in general.
Question about the relationship with additive manufacturing. Do you see that as something that can be incorporated into the system, or is that a competitive feature in the market?
I think this is very orthogonal. I would not see this as competition. Obviously, through additive, like 3D printing type of systems, you have a lot of flexibility as well. But if you think of some material properties where you think of, let's say, CNC machine parts, or think of industries that really need products at scale, still while having like flexibility. So, for example, having like low volume, high mix kind of applications. This is where the approach that I described here is actually gonna thrive. Additive manufacturing is a parallel track, and you can actually think of synergy effects between both. So in fact, we have one customer who's using a lot of 3D printed parts that still needs then some precise machining in order to get to like a sub-millimeter accuracy of parts. And this is where you get the best of both worlds. So you get the flexibility through 3D printing combined with the flexibility of robotics, and then get the best of both worlds. However, at least I'm not aware of very high volume use cases for additive manufacturing. Like typically you have smaller batches, and if you look at like electronics industry, automotive industry, general industry of like household appliances, for example, this is not where you have additive manufacturing. I believe we're technically at time. Maybe we have time for one more question, if there's one. Okay. In that case, please allow me to thank you all one more time. Thank you very much for your time this afternoon. Enjoy your time here in Washington. Thank you.